So for knowing the subshells of an electron shell, you do have to remember your rules for your quantum numbers will help you out with this one. So remember n, your principal quantum number, is any integer starting from 1. So 1, 2, 3, blah, 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 blah. But the rules for L is integers from 0 up to n minus 1. Integers from 0 to n minus 1. So depending on what the value of n is, there is a cap on L. So it's going to go 0, 1, 2, blah, 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 n minus 1. So it depends on what the value of n is, okay? So n is coming from the shell. Remember, n is your principal quantum number. N equals the principal, which is giving you the energy of the subshell, which is also known as the shell, right? So here where it says shell, that's telling you n. Okay, so for n equals 2, what is the maximum value for L? So remember, we also have those letter designations for n with L, which are used in subshell notation: S, P, D, and F. If you ever wonder, that is sharp, principal, diffuse, and fundamental. It's just labels which come from spectroscopy back in the olden days. So if we have the shell n equals 3, that is telling us the max value of L is n minus 1, which is 2, okay? So that means L can equal 0, 1, 2 only. So that means we only have 3s, 3p, or 3d that are allowable quantum states in this subshell, okay? There is no such thing as a 3f, okay? Now, if you don't believe me, check your periodic table, right? And you will see, like for n equals 3, you can find 3s, 3p, 4s comes in next, 3d, but in the F block, it starts at 4, okay? So there is no 3F, okay? Now I can't make this darn thing go away. Go away, I don't have space for you. All right, so for the n equals 1 shell, n equals 1, what is our max value of L? Well, our max value of L is n minus 1, and n is 1, so 1 minus 1 is 0. So there's only one possible value of L, which is 0. So that is just a 1s orbital. So you only have a 1s orbital when n equals 1. There is no such thing as a 1p, a 1d, or a 1f. Again, if you want to check the periodic table, sorry, periodic table, that's why we've only got 1s, okay? Then the next subshell you get to is 2s, okay? If we look at the example that ALEKS gave for the n equals 2 shell, the maximum value of L is going to be 1, right? 2 minus 1 is 1. So you've got two possible values of L, 0 and 1. So 0 would be the 2s, and 1 would be the 2p, which is why you only have 2s, 2p on the periodic table. There is no d, there is no 2d, there is no 2f. Sorry, it's hard for me to say those because they just don't exist, so I find it kind of difficult to even say it. Okay, so hopefully that gives you enough guidance to be able to smash that question.